As for Chapter 8, Logarithmic Function, we simply call log function. Lesson 1. This lesson will start a new chapter, log function. What is log function? Actually, log function, we need to make a big number to become small, especially if there are 10 to the power, for example, 100, then it's so large, so we need to make it smaller. So the main function for log is like this. At the beginning, take out your calculator, we do some exercise. For log function, you can see from calculator there's a log key here. So for example, question 1, log 10, then you press log and then 10, and then finally press exe, then you can get 1. Now try to use 2 minutes to finish question 2 to question 8 by using calculator. Okay, let's check it. Question 2, log 100, it is 2, 1000, it is 3. Finally, 10,000 for number 4 is 4. You can see the trend. Can you see it? If 10, there 1 0, the answer is 1. 2 0, 2. 3 0, 3. 4 0, 4. So it is very easy. So for example, $1 million. So what is the answer? Actually, you can check it. 1 2 3 4 5 6 6 0. So the answer is 6. So easy. Next, we'll check question 5 to question 8. This time it is a decimal. You can see this one is -1. This one -2, -3, -4. So easy. Same, we can look at the trend. We can look at the dots. If the dot is go backward, 1 time, then 1. 2 time, 2. 1 2 3, 3 time, -3. Lastly, 1 2 3 4. So it's -4. Actually, you can look at another way. If it is 0 point something, same, we can also count the 0. So for example, number 5, 1 0 here, 2 0, so 2, 3 0, 4 0, so -4, going backward. So you can see the trend. Actually, no need to use calculator. So for example, we have another function. We have another log. It is 0.000000001. Then you can see the 2 way. First way, you can see the jumping backward. 1 2 3 4 5 6 7 8. So it's -8. Or you know it's jumping backward, you can also count the 0. 1 2 3 4 5 6 7 8. So -x. Lastly, there one log I want to mention it. It is log 1. So you guess what is the answer of log 1? Actually, log 1 is 0. Okay, you can use the calculator, or you can look at this. Because log 10 is 1, that means no 0. So the answer is 0. Okay, so bear in mind, log 10 is 1 and then log 1 is 0. These two always happen in this chapter. So log 10 equal to 1, log 1 equal to 0. Okay, Let's see an exercise. Try to use 10 seconds to finish these two questions. Okay, let's check. Log, how many zero here? There are 7 zero, so it's positive 7. So for question 10, so same, this time it's going backward, so count the zero. So there's 6 zero, so it's negative 6. Or you can see the jumping 1 2 3 4 5 6, also negative 6. Next, we'll see the common log. First, we look at the first properties. The first property actually is the most powerful. We'll see a log m with power n. Then for this, actually we'll put the power n into the coefficient position. So it is n log m. N is a real number, so that means we will put the index to coefficient. Actually, at the same time, we can do like this in backward case. That means we can put the coefficient into the index. That is, it can be backward, forward and backward. Okay, let's see question 11. Question 11, we have log 10 power 7. So we can take the 7 to the front. That means the coefficient, it becomes 7 log 10. And then, what is log 10? Log 10 is 1. So 7 times 1. So the answer is 7. Now, try to use 1 minute to 12 to 14 without using calculator. Okay, let's check it. For question 12, as I said before, we take the index out, so it's 3.4 log 10. Log 10 is 1, so it is 3.4. For number 13, negative log 10. Log 10 is 1, so the answer is negative 9. Finally, actually no need to do the middle step. The answer is negative 8.2. Next, we'll learn another two properties. First one, if we see inside the log we have a multiplication, that means time, m times n, then we can separate into log m plus log n. Log m plus log n. And for divide, that means division, log m over n, then it becomes log m minus log n. So we can have a conclusion like this. If time, it becomes plus. If divide, it becomes minus. Okay, let's see an example. For example, this is a log 4 plus log 25. You see, it is plus. That means like this. If plus, it becomes time. So 4 times 25. So what is 4 times 25? 4 times 25 is 100. So log 100, do you remember? It is, there are 2 zeros, so the answer is 2. Now try to use 3 minutes to do question 15 to 18 without using calculator. Okay, now check it. For 15, we can see a plus case. So that means we time. So log 100 again. So 100, 2 0. So the answer is 2. Question 16. Log 40 times 25, because this is plus. So we can get log 1000. There are 3 zeros, so it is 3. Next, this time it is minus case. For minus case it is divide. So log 60 will divide by 6. So we can get log 10. What is log 10? Log 10 is 10, so it is 1. Finally, we have another minus case. Minus, so divide. 9 over 900. For this case, actually you can use calculator to place this only, not from the original question. So for 9 over 900, what you can get? You can get 0.01. So you see, jumping backward 2 times or 2 0, so it is -2. Next, let's see question 19. This time we can see their plus case, but you can see in the first term there's a coefficient. If there's a coefficient, we can't multiply the inside log, so we need to change something. So for the first term, we need to give the coefficient to index first, so it becomes 2 to the power 3, and then plus log 1 over 8. Then you can see both log, the coefficient do not have a number, that means it's 1, so we can combine. So to 2 to the power 3, it is 8, because plus, so times 1 over 8. Then you can use calculator to place this one. Actually, without using calculator, you also can do it. 8 cancel, that means it is log 1. So log 1 is equal to 0. Okay, next, try to use 2 minutes to finish question 20. Okay, let's try it. This time we can see a minus between 2 log. For the first log, no coefficient. But for second term, we have coefficient 2. So you can put the coefficient to index first. So it becomes 5 to the power 2 square. Put the index. Next, you see minus. That means it is divide. So log 1 over 4 divided by 5 square. For this part, you can use calculator. So it becomes log 0.01. So what it is? It is there 2, so it's -2. Next, we'll do an example for 22 first. We have log 8 over log 16. For this case, actually there are no equation for this, but we can simplify. And then look at the index. For 8, log x. X, what is the index for changing x? If you do know, you can use short division, divide by 2, divide by 2 to 2. So actually x is 2 to the power 3. How about 16? 16, same, you can divide by 2, you can make x, divide by 2, 4 to 2. So for log 16, actually it is log 2 to the power 4. Then we can put the index to front to coefficient for both numerator and denominator. So numerator becomes 3 log 2. For denominator, it is 4 log 2. You can see log 2 log 2. Then we can cancel it. So the answer is 3 over 4. Now try to finish question 21. Okay, let's check it. For 27, can we change 27 into 3 to the power something else? You can use short division. 3 times 9, 27, 3, 3. That means log 27, it is 3 to the power, there are 3, so power 3 over log 3. And then we can put the index to the front, like this. So it becomes 3 log 3 over log 3. Next, you can cancel log 3. So the answer is 3 only. Now let's have a conclusion. We learned the log function, and log 10 is 1. Log 100, 20 become 2. Look at the 0. And then log 1 is 0. And then we also learned 3 properties. If this is time log m times n, it is log m plus log n. If it is divide, it becomes log m minus log n. Or reverse, we have log m plus log n, it is log m times n. Log m minus log n, it is log m over n. Lastly, we have the index. We can move the index to the coefficient, move to the front. Or you go backward, you can move the coefficient to index. Now try to do the public exam question 2005. Okay, let's check it. For this question, we have a log a to the power b, b to the power a times each other. We need to simplify. First, we know it is time. That means we can apply c time, so it becomes log a to the power b plus log b to the power a. Next, we can apply e. That means we can move the index to the front. So like this. So it becomes b log a plus a log b. So the answer is D.